Hello friends, welcome to my channel. In this lecture of calculus, function part 3, we will be studying about piecewise defined function, investigation of function and types of the function. Before investigating function, let me tell you about piecewise defined function. Sometimes a function is written in a pieces, having different formula on different parts of its domain. Take an example of mod x. The right hand side of the equation means that the function equals x if x greater than equal to 0, that is the first formula, and equals minus x if x less than or equal to 0, that is second formula. Let me show you an animation for better understanding. Now, when x greater than or equal to 0, then mod x equal to x. Okay, and when x less than 0, then mod x equal to minus x. So now from the graph, can you write the domain of this function? Think mod x as machine, and no matter what input values you feed in terms of the real number, it always give you the non-negative real number. That means when you feed only positive real numbers as input, output is same as positive real numbers. For 0 as input, output of mod x is 0. So in the first formula it is written x greater than or equal to 0, mod x is x. And when you feed negative real numbers, then also mod x is giving you positive numbers. So mod x is the negative of the input values so that it can give you positive numbers. Here in the figure we can see when x equal to 2, the value of mod x is 2. Again, when x equal to minus 2, the value of the mod x is 2. So from the graph we can see the domain of the mod x is all real numbers. And what about range? We know range is the output of the machine. Here from the graph we can see range is from 0 to infinity. Take another example of piecewise defined function, which is the greatest integer function. The function whose value at any number x is the greatest integer less than or equal to x is known as greatest integer function. Think this function also as a machine where when your input is integer, then your output is also an integer. But when you feed any other real number except integer, then your machine will produce output a closest integer which is less than the input. Say for example, if you feed 2.5 as input to the machine, then what is the closest integer less than 2.5? Obviously the answer is 2. So this function will give you value 2. So let me show you the graph of the function. And you can see that the function is staircase type function where there is a break at every integer value, that is piecewise. By seeing the graph also you can tell the domain and range of the greatest integer function. So what is the domain of this function? As you can see, this function can take all real number as input. So domain is all real numbers. And what about range? Range is also all real numbers. And this function has another name. The name is integer floor function. This is another example of piecewise function. The name of this function is least integer function. It is same as the greatest integer function, but here difference is that we have to take the least integer which is greater than the input to the function. Say for an example, if you feed 2.5 to the function, then what will be its output? Its output will be the least integer which is greater than 2.5, and the answer is obviously 3. It has another name also. The name is integer ceiling function. So by looking at the graph, you can tell what is the domain and range of this least integer function. The domain and range of this least integer function is all real numbers. While doing the investigation of function, it is advisable to determine the following, such as we have to find the domain of definition of the function, we have to check whether the function is odd or even, again we have to check whether the function is periodic or not, is the function bounded, and what is the maximum and minimum values and zeros of the function. Now let us understand how we can tell whether function is increasing or decreasing. If the graph of a function climbs or rises as you move from left to right, we say that the function is increasing. If the graph falls as you move from left to right, the function is decreasing. Suppose f be the function defined on an interval, say I, and I already talked about the interval in my previous lecture. Let x1 and x2 be the any two number within interval I. If f of x2 is greater than f of x1, whenever x1 greater than x2, we can say the function is strictly increasing. Again, if f of x2 less than f of x1, whenever x1 is less than x2, we can say the function is strictly decreasing. It is important to realize that the definition of increasing and decreasing function must be satisfied for every pair of points x1 and x2 in interval I with x1 less than x2. So take an example, f of x equal to, within second bracket I have written, minus x when x belongs to an open interval from minus infinity to 0. F of x equal to x square when x belongs to closed interval 0 to 1. F of x equal to 1 when x belongs to open interval 1 to positive infinity. Let me show you the graph. So it is the graph of y equal to minus x. Then it is the graph of y equal to x square. And this part is the graph of f of x equal to 1. So by looking at the graph, can you tell where the function is increasing, decreasing, and neither increasing nor decreasing? As I have already told the definition of increasing and decreasing, we can see when you move from left to right, we can see the function is strictly decreasing in an open interval from minus infinity to 0. Then function is strictly increasing from 0 to 1. and then from 1 to infinity the function is neither increasing nor decreasing. Let us study even and odd function. The graphs of even and odd function have characteristic symmetry properties. A function y equal to f of x is an even function of x if f of minus x equal to f of x. Odd function of x if f of minus x equal to minus of f of x for every x in the function's domain. So we can think even function as machine where whenever you feed say x equal to 1 or negative of same value, that is x equal to minus 1, we get the same output. Similarly, odd function is like a machine where when you feed x equal to 1 and when you feed x equal to minus 1, you get the output of x equal to minus 1 is equal to the negative of the output when you feed x equal to 1. So why the name even or odd? The name come from the powers of x. If y is an even power of x, such as y equal to x square or y equal to x to the power 4, then it is an even function of x because minus x whole square equal to x square and minus x whole to the power 4 equal to x to the power 4. If y is an odd power of x, as in y equal to x or y equal to x cube, it is an odd function because minus x whole to the power 1 equal to minus x and minus x whole cube equal to minus x cube. So see in the adjacent picture, figure 1 shows you the graph of y equal to x square, which is an even function. Here you can see f of x equal to x square, then we will find f of minus x by putting minus x instead of x in the function. We will get f of minus x equal to minus x whole square. So f of minus x equal to f of x. Similarly, see in figure 2, which is the graph of y equal to x cube. So this is an odd function. Why? We can see f of x equal to x cube. Now replacing x by minus x in the function, we get f of minus x equal to minus x whole cube equal to minus x cube, which is equal to minus of f of x. And also one thing we can see from the graph of an even function is symmetric about the y-axis. Since f of minus x equal to f of x. By symmetry we mean, suppose in figure 1, if we choose x equal to 1, then what is the value of y equal to x square? The value of y equal to x square is 1. Similarly, if we choose x equal to minus 1, we again get the value of minus 1 is 1. That means with respect to y-axis, this graph has a symmetry. For every value of x to the right of y-axis, we get the same output if we take the value of x to the left of y-axis. That is, this graph is symmetric about y-axis. A point x comma y lies on the graph if and only if the point minus x comma y lies on the graph of even function. And in figure 2, we see that odd function is symmetric about the origin. Since f of minus x equal to minus of f of x, a point x comma y lies on the graph if and only if the point minus x comma minus y lies on the graph. Equivalently, a graph is symmetric about the origin if a rotation of 180 degree about the origin leaves the graph unchanged. Notice that the definition implies that both x and minus x must be in the domain of f. What is periodic function? A function is periodic if there exists a number t greater than 0 such that f of x plus t equal to f of x, and both x and x plus t must belong to the domain of the function. The least number t is called the period of the function f of x. So now let us see the graph of a periodic function. This is a graph of a periodic function. The function is sine of x, whose maximum value is 1 and minimum value is minus 1. As I have already told that the periodic function is f of x plus t equal to f of x. Think periodic function as a machine. When you feed x as an input to the machine, you get some output, and for every x there exists a number x plus t. When you feed that number as input to the machine, you get the same output. So now choose x equal to pi by 2 to the input of the machine. Related to this example, you will get the output 1. Now from the graph you can see at x equal to 5 pi by 2 you will get the same output, that is 1, and again at x equal to minus 3 pi by 2 you will get the same output 1. Now if you check the difference of 5 pi by 2 and pi by 2, you can see the difference is 2 pi. Again, if you check the difference of pi by 2 and minus 3 pi by 2, you will get the difference of 2 pi. That means here the value of capital T, which is the least number, is equal to 2 pi. So this function is a periodic function whose t value is 2 pi. That means for every x value as input to the machine, you will get some output. There exists a number x plus 2 pi which will give you the same output. Now let us talk about bounded function. Look at the nearby picture. We can see the graph of, say, triangle, and you can see the value of this triangular function is always less than or equal to the value 2. So we can say that this function is bounded and the upper limit is 2. So what is bounded function? A function is said to be bounded above or below on the set x if there exists a number m or small m such that f of x less than or equal to capital M for all x belongs to set x, or small m less than or equal to f of x for all x belongs to capital X. So in the nearby picture I have told you only the upper limit, that is capital M. Can you guess what is the lower limit of this function? Obviously, the lower limit is 0. So, here the small m is 0. Now, let us see some type of a function. Linear function, power function, polynomials, rational functions, algebraic functions, trigonometric function, exponential functions, logarithm functions, and transcendental functions. So, what is linear function? A function of the form of f of x equal to m into x plus b, where m and b are the real valued constant, is called a linear function. Now, look at the adjacent picture, which shows an array of lines f of x equal to mx, where b equal to 0. So, this line passes through the origin, because y equal to mx is a straight line which passes through the origin. The function f of x equal to x, where m equal to 1 and b equal to 0, is shown by red color line in the figure, and it is also known as the identity function. Another line which is shown in the green color is y equal to mx, where m equal to 0.5 and b equal to 0. Now, by looking at this graph, we can say why this function is known as linear function. The word linear means straight. Since f of x equal to mx plus b is an equation of a straight line, so this function is known as linear function. Sometimes we come to the word that is proportional. Now, two variables y and x are proportional to one another if one is always a constant multiple of the other. That is, if y equal to kx for some non-zero constant k, then we can say y is proportional to x. So, the equation related to the proportionality is also a linear function, and this type of equation is very widely used in physics. Now, let us look into the power function. A function of the form f of x equal to x to the power a, where a is constant. Now, here several cases we have to consider. Suppose a equal to n, where n is a positive integer, as for example y equal to x square, where 2 is an integer whose graph is shown in the figure 1, and a equal to -1 or -2, example y equal to 1 by x square. That means 1 by x square can be written as x to the power -2, where the a value is -2. The graph of this function is shown in figure 2, and another case is a equal to half, 1 by 3, 3 by 2 and 2 by 3. Example y equal to root over x, or we can write x to the power half in figure 3. These three type of cases are very important power function which you will encounter mostly in calculus. So I have drawn the graph in this slide. Better you remember this graph. Now let us look into the polynomials, rational function and algebraic function. So what is polynomial? A polynomial is a function of the form f of x equal to a n x to the power n plus a n minus 1 x to the power n minus 1 and so on up to a 0, where n is a non-negative integer and the numbers a0 to an are real constant called the coefficients of the polynomial. Here n is known as degree of the polynomial if n greater than 0 and an not equal to 0. The most common example of a polynomial is a quadratic function where we can take the value of n equal to 2. And linear function is also an example of a polynomial function if we can take the value of n equal to 1. So here you can see the last two part a1x plus a0, and if rest other parts are not included, then you can say a1x plus a0 is a linear function. And similarly, if you include one more term here, suppose a2x square plus a1x plus a0, then it becomes a quadratic where degree of a polynomial is 2. Now what is rational function? A rational function of the form f of x equal to p of x by q of x, where p of x and q of x are the polynomials. What is an algebraic function? An algebraic function is a function which is constructed by the polynomials using algebraic operation, say addition, subtraction, multiplication, division, and taking roots of the polynomials. Now what is trigonometric function? 6 trigonometric function we already know, that is sine, cosine, secant, cosecant, tan and cotan. So the function which uses this type of 6 functions is known as trigonometric function. We will explain trigonometric function in my next lecture in details, and we will try to solve the domain and range of this trigonometric function also. Now what is exponential and logarithmic function? Function of the form f of x equal to a to the power x, where the base a is greater than 0 and it is a positive constant and a not equal to 1 are called exponential function. So in the figure 1 you can see I have drawn a graph of one exponential function which is 2 to the power x. All the exponential function has one similarity. Can you tell? The similarity is that at x equal to 0, all exponential function is always 1. Now what is logarithm function? Function of the form f of x equal to log x, where the base a equal to 1 is a positive constant. Logarithm function are the inverse function of the exponential function. We will also talk about inverse function in my next lecture in detail. So let me show you the graph of a logarithm function. Here you can say this is a graph of log x where base is 2. This is an inverse function of the exponential function 2 to the power x. All log function has one common similarity, that at x equal to 1 all log function are 0. Now what are transcendental functions? These are the functions that are not algebraic. As I have already told, what is algebraic function? Algebraic functions are constructed from polynomials by addition, subtraction, multiplication and taking square root, division, etc. But transcendental functions are not algebraic. They include the trigonometric, inverse trigonometric, exponential and logarithm function and many other functions as well. So in this lecture we talked about piecewise defined function, investigation of a function and type of a function. So one question may come to your mind that I have told about the type of the function but not about the domain and range of the type of the function. So in my next lecture we will see in detail that how to calculate the domain of different types of function, especially quadratic function, trigonometric function and inverse function. So thanks for watching and please subscribe and stay at home and stay safe.